All right, so today we're starting Unit 8. Unit 8 is the introduction of radians. Unit 8 will also, after we learn radians, we'll introduce how to graph the trig functions and how to transform the trig functions. So we are going to prep for Unit 8 today by introducing radians. So the topic today is radians and degrees. How are they related? How do you move to a language of radians instead of degrees? So essential questions, that does not say distance, so I'm going to fix that as I go. How do I find the distance? A distance on the unit circle. What is a radian? And how do I convert between radians and degrees? Okay, so we're going to start. Distances on the unit circle. Okay, so a distance on the unit circle means I'm going to travel a portion of the circumference of the unit circle. So let's sketch a unit circle. Shall we? We'll just sketch a unit circle. And that's going to be a crooked line. Try that again. Okay. So there's our X. Here's our Y. Do you guys need me to scroll in and zoom in a little bit? Or are we good? Okay. So actually, I think I'm going to change the size of my page here just a little bit. We're fine. Okay. So unit circle, what's the radius? 1. So let's just mark a point that's about the same distance. One distance to the left, one to the right, one down, one up. It's just a sketch. Certainly doesn't have to be perfect. Of course, we know Faith's is going to be perfect right now. And mine is going to be perfect because I'm going to have it I'm going to draw a circle and it's going to turn it into a circle. Look at that. I love it. Okay, so you sketch while I just make mine look really good. Okay, it's not perfect, but it's good enough. Okay, here we go. Here's what we know. It has a radius of 1. So our coordinates here are 1, 0. And our coordinate up here is 0, 1. And over here is negative 1, 0. Down here. Things we know, okay? So unit circle, okay? So if I wanted to know what's the distance around the entire unit circle, the whole thing, I want to know what's the circumference. That's the distance. That's the linear distance if I want to measure it. Like pretend it's a string in a circle and I snip the string and I stretch it out and I measure the string. What's the distance or the length of that string? So remind me, what's the formula for the circumference of a circle?
Diameter pi r squared.
No. Pi r squared is area. 2 pi radius or pi times diameter. Okay, but we're going to go with 2 pi radius. Okay, so now that we know that, what's the distance around or the circumference of the unit circle? 2 pi times 1. So that's the distance. So it's just 2 pi. Now 2 pi is a perfect exact value, and we like this in trig. Its approximate value is about 6.28, 3.14 times 2. But in trig, we like exact values over approximate values as often as we can find them. Sometimes we just do approximate values so that we can get an idea of what that looks like, right? 2 pi, that doesn't really look like much, but 6.28, you understand that. Okay, so that's the distance around the unit circle. So let's take a couple questions here. Example 1, how far will a point travel if it goes 1/4, 1/12, 3/8, and 5/6 of the way around the unit circle? So I'm looking for, of course, a distance. I want to know how far is it going to travel. And so I think 1/4 of the way around the unit circle is pretty easy to see. And that's because our unit circle is centered at the origin and it's already cut into 1/4. So we could say, okay, so the point starts here and it just cruises around and it travels to here. And that would be the distance that it would travel. But what is that distance? Okay, so we've figured out where the point stops. But in terms of distance, how far is that? So what we could do is take 2 pi, which is the total distance of around the circle, and just multiply that times 1/4. Simple information here. I'm going to go ahead and put a 1 under that just so I can cross simplify. So 2 goes into 4 twice, and that gives us pi over 2, or if you'd rather, 1/2 of pi. So what we just determined is that if this is 0, then this distance from here to here is pi over 2, or pi cut in half. That's interesting. So the distance is pi over 2, or 1/2 pi. Sometimes people understand 1/2 pi better than pi cut in half. And that's supposed to be a box, but it is what it is. You guys got it? All right. So how about let's do 1/12? Now, maybe that's not as easy to imagine because we'd have to go and cut our circle instead of into fourths into 12 pieces. Now, we could think about that for a second. Let's think about that. Think about it. 12ths. I didn't hear what you said, Austin, but you got every quadrant in thirds. That's right. You could do that. Or you could just take 360 divided by 12. That's 30 degrees. And you know what that kind of looks like. Or lots of things. So let's go ahead and do the math. And then we'll draw the picture. So I'll just switch colors so we know it's a different problem here. So 2 pi times 1/12. Put a 1 under that. Cross simplify. It's not like this math is, I'm going to write the answer underneath because I want to make sure I have enough space for the other problems. We have pi over 6, or 1/6 of pi. Well, that's interesting. So let's go back to this problem over here. Actually, let's go back to the circumference of the circle. If the circumference of the circle is 2 pi going all the way around, what is it if I only go half the way around? Pi. So with this problem down here, so we got pi over 2, pi cut in half. This is we only want 1/6 of pi. So we need to cut pi, which is half the circle, into 6 pieces. Does that make sense? Okay. So we go 1, 2, 3, 4, 5, 6. And we only go 1/6. So that's a distance of pi over 6. I'm going to put a little spot there. Of course, I didn't do a very good job of drawing that into it. You have a little bit more control. I can't see what I'm doing. I have to look at my screen. No excuses. I'm having trouble going back to my tablet when I've been using my iPad for so long. Okay, so 3/8. Your turn. Give it a go. Let's see how you do. I'm going to press pause. So try it, come back, press play, see how you did. So here I got 3 pi over 4, or 3/4 pi. So what I did was I took pi units and I cut it into 4 pieces and I traveled 3 out of those 4 pieces. 3/4 pi. Okay, 5/6. Okay, so this was a little different. 5/6 of the whole unit circle, that's like almost the whole thing, right? So if we do 2 pi times 5/6, we could just basically simplify that to 5 pi over 3, or 5/3 pi. That's an improper fraction, right? 5/3 is the same as 1 2/3, right? So it's kind of like saying 1 pi plus 2/3 of the other side of pi. So basically you could just cut the bottom of pi, of the bottom unit, or the bottom half of the unit circle in thirds, right? So here's pi, and then that's pi plus 1/3. Here's pi plus 2/3. And so you would be traveling from here all the way to there to 5 pi over 3. Okay? And so, and the reason I have a totally valid reason for teaching it like this, I could just show it to you mathematically, but you're going to have to find all of your measures in radians on the unit circle, and this ties into that. So I want you to see how you're breaking up the unit circle. Okay? All right. So let's do a couple more. So on the unit circle, mark the point determined by each of the following real numbers. 9 pi over 4 and negative 7 pi over 6. Okay, so 9 pi over 4, definitely an improper fraction, right? So something that I like to do is just to look at it in a really logical way here. How many pies is that? How many 4s are in 9?
2.
Okay, this is really hard math. With 1/4 left over. So that's 2 pies plus 1/4 pi. That's what 9/4 pi means. So 2 pi means I'm going all the way around the unit circle, and then I'm going to do 1/4 of 1 pi, right? So that would be right there, because we're going to go all the way around and then stop at 1/4 of the way. So this is the point. This time we're just marking a point. We're not finding the distance, we're marking the point. So it looks like 9/4 pi is equivalent or coterminal to 1/4 pi. So coterminal, that's coming tomorrow. Questions about that? Okay, let's do negative. So why don't you try negative 7/6? I'm going to press pause. You come back when you're done. See how you did. Okay, so we figured out that negative 7 pi over 6 is the same as negative 1 1/6 pi. So we separated that into one whole negative pi. So we went backwards to negative pi, and then we backed it up another 1/6 of pi. So we took the top portion of the unit circle and cut it into 6 pieces, and we only went backwards 1/6. And that's the position that we ended up in. So there you go. So that's just finding points on the unit circle. Now let's talk about radians. Okay, so on to the back. So listen, radians are critical. So in human history, this is going to be so fun for the people listening to the video because I'm not going to write anything. In human history, people in ancient civilizations figured out how to measure the distance or not, but the angle measure of a full revolution. And some civilizations would use astronomy. So they'd watch a star or a planet move across the sky, and they'd notice that it would take 360 days approximately for that planet to come back and rest in the same position in the sky. So they would consider that every night it would move 1/360th of the way around a circle. So this is where possibly we got 360 degrees from. Also, you'll know that our calendar is 365 days, but old calendars, I believe, used to be 360 days. And so every day represented 1/360th. So there's different theories on where 360 degrees came from, but that's a human construct. Radian measure, real numbers, okay, has to do with circles and things we know about circles like, gentlemen, the circumference of a circle is 2 pi times the radius. And there was a lot of studies about how that's actually always the case. And so sometimes we'd rather work in radians because they give us, that's a relationship to radius. And a circle always represents a perfect distance from the center all the way around, one full revolution. So a radian measure is this. It's another way, a radian measure is another way to measure angles And what we want you to do is convert to radians. Leave degrees behind. Convert to radians. Okay? Part of the reason is that radian measures or radians provide real number values. If we're going to graph a sine function or a cosine function, we need to do it in radians so we can see the oscillations in the sine waves. Okay. Also, radians are commonly used as a measure in calculus. Also in other sciences, but I'm not really versed in which sciences because, you know, that's not my gig. I'm a math person. Okay. So let's define a radian. What is a radian? What does it look like? So a radian defined, this is a noun. It's a thing. Okay. It's the central angle measure that I'm going to say encloses. I think I could also say subtends, but I'm just going to go with encloses the distance on a circle. Okay, so you know that's, I'm talking about part of a circumference here because the distance on a circle is a part of a circumference. That is the same length as, guess what? What does radian sound like? Same length as the radius. That's right. Okay. So in a second, I'm going to sketch some pictures out so that we can see what that looks like and kind of define radian in pictures. Okay. Radians are pretty big. What? Same. Oh, length. Thank you. Squeeze that in there. The same length as the radius. All right. Okay. So something to note, just a side note that's really important. You know how when we mark degrees, we'll say like theta equals 50 degrees. That's what we do, and we make, and that's how we know it's being measured in degrees. Well, in radians, we don't do anything. We don't write anything. We don't label it anything. If you see theta equals a number, that is assumed that we're speaking in radians. Okay, radians don't get labels like degrees do because radians are just real numbers. Okay, all right, so let's just do on the unit circle, well, any circle, doesn't matter, centered, so our central angle can be at the origin. We can see the center. So let's start with this picture, and this is the radius. You agree, this is the radius. Okay, so what I'm looking for is an angle that if I were to take this radius and stretch it out with a piece of string, and I'd measure it with a piece of string, and I'd get that measure and snip my string. It's exactly the length of the radius. And then I wrapped that radius around the distance of the circle. How far would it go? So we could just kind of eyeball it. It'd probably be about that distance. So this distance from here to here would be considered the same length as the radius. Now, the radian is the angle that, pretend I did a good job. I'm going to go back and do a better job. That encloses that radius that's wrapped around. It's kind of called a radius wrap or a radian wrap. So this is theta equals 1 radian. Now 1 radian is about 57 degrees. Okay, 57 degrees, you know what that looks like. Start thinking of 57 degrees as 1 radian. Do you understand that? Yes? Or no? Okay, so let's see if we can identify what 2 radians might look like. About. Okay, so we'd come out here and 1 distance of the radius. So that would be a radius. And then maybe we come out here and we're just sketching, so it's okay. Okay, because we're labeling it R. Ooh, that's not very good. Let me back that up. And then we draw the angle that encloses or subtends to radius lengths on the unit circle, and that's theta equals, not r, 2. That's 2 radians. You guys get the idea? Okay, let's do 3 because I want you to see something. Okay, so here we have our radius, and we have one length of the radius approximately, and another length of the radius approximately, and then we have another length of the radius approximately, and we go like this, and we draw our angle. Theta equals what? 3 radians. 3 radians. Now we write 3, but we say 3 radians. Notice how close that is to here. Now, I already told you, half the distance around the circle is pi. Well, this is 3. Pi is approximately, do you see that little portion that's left? Yeah. And I haven't drawn it to scale very well. I do have it up here on the board, and it's drawn to scale, and I used my protractor, so it's pretty good. But you can see now, hopefully, the relationship here, that half the distance of the circle in radians is going to be exactly pi. Exactly pi. Let's keep going. Let's do 4. 4 radians. Questions? You can ask them, you know. You need clarification. You can make me earn my paycheck. You don't have to make my job so easy and just listen to what I say. So that's theta equals 4 radians, because that angle encloses the distance of 4 radii wrapped around the unit circle. So look, it takes more than 4 radii to get around the circle. Following me? Okay, let's do 5. So 1, 2, I know, we're almost done. We just have to get to 6 so you can see the last part. So now I'm into quadrant 4, and here we have theta is 5 radians. So look at how big 5 radians is. Compare that to 5 degrees. Like here's 5 degrees. Here's 5 radians. Totally different. Okay, last one, 6. Oh, that one's the problem. Let's go here. I can hear you. I can hear you complaining. Oh, that wasn't a good thing to say. Uh-huh. Whatever, dude. You're in trouble. Okay, so this is theta equals 6 radians. Notice I'm almost finished with the circle. Not 0.14, because this is 2 times 3.14, which is approximately 6.28 radians. So you can see that little bit of a radian, or a little bit more than a quarter of a radian, 28% of a radian. And so do you see the relationship between 2 pi times the radius, which is the circumference of the circle, and 2 pi radians, which is the angle measure if you go all the way around 1 full revolution? Okay? Totally related. This is why in calculus we like radians. Really clear, works in radii, and it's always a perfect number, like a real number, not a degree. Okay, so now I'm going to give you some conversions, because now you need to learn how to convert your brain from degrees into radians. So let's start with an equation or a statement that we know is true. We now know, we've proved to ourselves, hopefully, that 360 degrees is equivalent to 2 pi radians. Now remember, we don't write radians, we just say 2 pi. Okay, we know this is true. And we can, from there, say, okay, then it stands to reason that 180 degrees is just 1 pi. You just divide both sides by 2, and there you go. So what does 1 degree equal? Or what does 1 radian equal? So let's take this equation here and split it into 2 so that we can convert from degrees to radians and convert from radians to degrees. So let's go degrees to radians. Okay, so if I'm going to convert degrees to radians, okay, I'm just going to take this equation, 180 degrees equals pi radians, and I'm going to divide that by 180 degrees. So I know 1 degree is equal to pi divided by 180 degrees. This is a true statement. Okay, anytime you see pi over 180 degrees, that equals 1. It equals 1 degree. So if I want to go from degrees to radians, here's what I do. I say, okay, I have x degrees, and I want to convert that to radians. So I'm going to multiply that times pi divided by 180 degrees. Now here's the reason that this converts to radians, okay, because this is pi, and I'm going to write pi rads over 180 degrees for the purpose of just giving you an example. But over here, I'm also going to put a 1 under here, because what we're going to do is a dimensional analysis. I don't want degrees. What I want is radians, because I'm going from degrees to radians. So what I'd like to be able to do is cross simplify and get rid of this degree mark. If I get a degree in the numerator and across from it, I'm multiplying by a degree in the denominator. The degrees are gone. All I'm left with is radians. And so this is how you convert degrees to radians. You choose pi over 180 degrees so that you can cross simplify the degree mark and get rid of it and be left with the dimension radians. Questions about that? Okay, so if I'm going to go, I'll do the other one in black, from radians to degrees. Kind of out of space, so I'm going to scooch over a little bit, and I'm going to do some math up here. All right, so if I want to know, I'll go back to this statement. What's 1 radian equal? So I got pi radians. How do I turn that into 1? What do I divide? No, I want 1 radian. So I'm going to divide by pi and divide by pi. And so I get 1 radian equals 180 degrees by pi. True statement. True statement. 1 radian is 180 degrees divided by pi. Okay. Or 1 is equal to 180 degrees by pi. Okay, so if I want to go rads to degrees, okay, so let's say I have x and I'm going to label it rads. And I want to get rid of rads, right? And be left with degrees. So I put pi rads in the denominator, and I put 180 degrees in the numerator, and then I put the rads over 1, just so you can see the fraction. That way I can cancel the dimension radians, and I'm left with the dimension degrees. Okay, this way you don't have to memorize which formula do you use. Just think, what am I trying to get rid of? Radians. Okay, so I'm going to put radians in the denominator. What if I'm trying to find degrees? I put radians in the denominator. If I'm trying to find radians, I put degrees in the denominator. Okay, so let's give it a try. So we're trying to learn how to convert degrees into radians in our language. So 120 degrees, what does that mean? All right, so we're going to take 120 degrees. I'm going to pop a 1 under it. And what do I want to get rid of? So I'm going to put 180 degrees in the denominator and pi. Remember, that just equals 1. That just equals 1. Okay. So now we can just quickly cross simplify. We'll get rid of degrees. And I think 60 goes into both of these, right? So I can make that a 2, make that a 3, and then multiply. So that's 2 pi over 3. Or if you'd rather, 2/3 pi. But I like 2 pi over 3. But sometimes 2/3 of pi makes sense. Okay, questions? Okay, we'll zip to the next one then. This one you need a calculator for. All right, so we're taking negative 209. Oh, we'll put it over 1. I don't know why I'm writing it again. I might just move this stuff out of the way here. Okay, we're going to multiply that times pi over 180 degrees so we can simplify that dimension. And then you guys have to plug in the calculator because I don't have the answer. So give me an exact answer in terms of pi, and then we'll convert it to an approximate answer so you can see how many radians it is in decimal form. Somebody's got to do it. I got 1 over 720. I haven't seen. Yeah, that's a, so hit the little conversion button right above enter. So what's the top number? Is it 1189 or what is it? Over 720? Okay, thank you. Pi, right? Negative 1189 pi over 720. So that's multiplying it out. That's why I like those little calculators, because they'll simplify that. Now let's convert that to about how many negative radians is that? Is it 5.19? Somebody do a conversion. Hit the conversion button. What did you say it was, Ebony? There we go. So that's negative 5.19 rads. Or it's exactly negative 1189 pi over 720. Okay? So there you have that. Now let's go the other way. Questions? Well, we need to finish. This video is already 31 minutes long. Let's go. All right. So we're going to take this and convert it to degrees. So we have 3 pi over 4. And we want to get rid of rads, right? So I'm going to write rads up here. So pi rads in the denominator, 180 degrees in the numerator. Then we can cancel. Rads go, pi goes, right? And 4 goes into 180 degrees 45 times. And so we have 3 times 45 degrees, which is 135 degrees. All right, lastly, we have 8.5 radians. So we go, all right, we could just put that over 1 since we already have it written out. So 8.5 radians over 1 times 180 degrees. You don't need me anymore. I mean, you guys are totally fine by now. Pi rads, cancel, cancel. You guys have to plug that in the calculator because I don't have it. It's something over pi, like 1530 or something like that. Somebody give me 8.5 times 180. Hurry, hurry. 1530 over pi degrees, which is approximately to the nearest degree 497. Help me out. 487. That's not a 7. We'll try that again. 487 degrees approximately. So look at how little that is. 8.5 radians is a monster in degrees. Okay, so there you go. So there's your notes for today. Now what I'd like to do is go onto your unit circle and then put your radians on there, and then your unit circle will be complete. For those of you that are not here, you're going to have to find somebody that has a completed unit circle and maybe they'll let you borrow it. Or go online and look it up because completed unit circles are everywhere online.